Hi everyone, welcome to this lecture series on Oracle Cloud Infrastructure Foundations. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this particular module, we will look at the various OCI storage services. We'll look at the various storage services within OCI, starting with block volume, local NVMe, file storage, object storage, and archive storage, and look at its various characteristics and use cases. So let's get started. Well, before we dive deep into the various storage services available, it's important to remember why do we have so many services available in the first place. And that the reason is you have different storage requirements, and depending on your requirement you might choose a particular storage service over another. So what are these requirements? At a very high level, these are some of the requirements you have. Storage is persistent versus non-persistent. What kind of storage are you looking at? Is it database? Is it videos? Is it audio? Is it photos? Is it text? What kind of performance are you looking at? And when we talk about performance, there are different characteristics. How much is the max capacity available to you? What is your input output per second IOPS? How much is the throughput? And so on and so forth. What is the durability of the data you are looking at? And when we say durability, typically what we mean is how durable is the data, meaning how many copies of data do you make or you keep? What is the connectivity? What does the connectivity look like? Are you trying to connect to a local storage, direct attached storage, or you're trying to connect to a remote storage? How does your application access the data? And then finally, related to connectivity is the kind of protocol you are planning to use. Is it block storage? Is it file storage or versus another kind of storage? So these are some of the requirements, and depending on your requirements, you might choose one storage service versus another. So the various offerings we have block volume, we have local NVMe. Local NVMe is also called sometimes local NVMe disks, file storage, object storage, and then archive storage. So let's get started and look into each of them in a little bit more detail. So before we go and talk about OCI block volume service, first let's talk about what is block storage. Well, think about block storage as a hard drive in your server, except that the hard drive happens to be installed in a remote chassis. So the emphasis here is remote. So it's a remote storage, network storage. In a block storage, data is typically stored on device in fixed size blocks. So fixed size blocks, and that's the reason if you look at even our icons for block storage, you have these kind of blocks, right? And what they imply is your data coming in, data going out is comes and goes out in these chunks of data called fixed size chunks called blocks. Your operating system accesses block storage as mounted drive volume, and your application file systems decide how blocks are combined and accessed. Like I said, the blocks come out like go in or come out, and then your file systems, your apps, decide how they get combined and accessed because they're broken down and stored in chunks. Data is stored without any higher level metadata for data format, type, or ownership. So keep that in mind. There is no metadata which is stored. And then this is the underlying offering on which you could install any kind of file system. So this is sort of the basics of your storage. So you could install different file systems on block storage. So things like Windows uses NTFS, VMware servers use VMFS, but underneath both of those, they are using block storage. And then commonly block storage is deployed in storage area networks if you're coming from on-premises environments. So let's look at in an OCI environment, what is the block volume service? The first thing to note here is it's storage for compute instances. So you have a compute instance running here, and then you have remote servers. So keep in mind, like I said, these are your remote storage. It's not local storage, it's network storage. So you have storage server running here, and then basically the compute instances is connecting to those storage servers, and accessing your data. Now there are two flavors of block volume. One is called boot volume. The second one is called block volume. Boot volume is the operating system disk, and you can see here with a different color. This is where your operating system is stored, and your instance boots using this boot volume that is also remote. It's a flavor of block volume. And block volume, when we say, even though it also encompasses boot volume, we typically mean data disks. So I have only shown one disk here, but you can have multiple disks attached to the same compute instance. You do that. So remember, what is block volume? Storage for compute instances. Two flavors: boot volume, block volume. Why do we use block volume? Well, the most important reason you use block volume, you want to store data independently and beyond the lifespan of compute instance. What do I mean by that? This instance dies, your boot volume and your data volumes are all still available to you. So that is one of the main reasons, data durability, why you would use a block volume. What are the use cases? Well, databases. So databases can run here. The individual data is actually stored as blocks or chunks of data. Exchange doesn't supports only block level storage. VMware, we talked about VMFS. When you use VMware virtualized servers, they use this kind of storage on block storage. And then, like we talked about, boot volumes. Instances are configured to boot from public from block level storage in most of the public clouds. Well, so we talked about block volume being highly durable. So what do we mean by that? Well, what we mean by that is storage. Block volume service actually stores replica of data in three separate fault domains. So let's say this is the storage which is getting connected here, accessed here. So block volume service would actually make two more copies here in another two other fault domains. The idea being, if let's say if this fault domain becomes unavailable for some reason, your boot volume and your block volumes are still available to your compute instance. Now with this, you don't have to configure any software based protection, so you don't have to do like RAID 10, etc. Now if we do this, is your job done? Do you also need to do anything? Actually, your job is not done, because this is what our service is doing to make it fault tolerant. But what if you have cases where you accidentally delete data or data gets corrupted? Those cases, you should do this thing called periodic backups, block volume. You should do backups, because if you don't have backups, then literally, your data is at risk. Now, OCI also allows automated scheduled backups. How do these work? Well, what happens is you have a block volume here. You can take a backup. We do a backup. It actually goes to our object storage. And from that backup, you could create a new volume, and then you can attach it to a compute instance. And you could do that in a different AD also. You could of course do it same AD, but if your region has multiple ADs, you could actually do that backup and restore to another volume in another AD. So if let's say this AD goes down for some reason, because you have a backup stored here, very quickly, or you could automate it, your instance could be up and running, your application could be up and running in another AD in the same region. Not only that, there is also a feature called block volume. There is also a cross region copy feature, where you can copy block volume backups from one region to another. So you could take the backup from here and you could do this. Why would you do that? Disaster recovery, because you want to do the same thing across regions, because you don't know if one region becomes unavailable, you can still have your application running in another regions. And not only this, you can also schedule these backups. What I just talked about is a manual backup. You don't have to do manual backups. You could actually schedule this based on a policy, etc. You could write, and you could schedule your backups. So that's one of the most important characteristics of a block volume service. The last thing you need to know on a block volume are the different tiers of block volume. Well, we have three tiers of block volume, starting with basic. Now, the idea with basic is it's for large sequential IO. So you can see that the number of IOPS is pretty small here, but the throughput is pretty decent. So this is for data warehouse, big data, streaming, log processing kind of scenarios, where you want to read a lot of data, a big chunk of data. You don't want to read very quickly, or not as quickly as, let's say, a database, but you want to read a bigger chunk. So bigger chunk. So that's basic. The second one is balanced, sort of the middle tier. Right here, it's a balanced mix of IOPS and throughput. You get a fairly decent IOPS, 60 IOPS per gig, and you get a fairly decent throughput. So these are good for things like random IO, boot disks. You want to boot very quickly, right? Databases, etc. Transactional databases, you could use this. And then the last one is higher performance. In this one, you get actually really high IOPS per gig, the highest, and you actually get pretty good throughput. So this is optimal if you're running mission critical databases. Now, the thing to keep in mind, each of these tiers, you can create a 50 gig volume, that's the minimum, and the maximum is 32 terabyte. And you could attach 32 volumes per instance. So the total volume storage you can do is 32 volumes into each of the volume can be 32 terabyte. So this is close to 1 petabyte. That's mind boggling. This is how much storage your VMs can actually leverage. Now, of course, there are lots of limits around how much they can use, but this you could go as high as this. And the other thing to keep in mind is data is encrypted at rest and in transit, and there are two ways to do that. You can let Oracle manage the keys, encryption keys, or you could control your own keys. And there's a service called key management. You could leverage that to create your own keys and manage your encryption. Well, so that's all about block volume. Let's move quickly to the other flavor of storage we have called local NVMe. Now, this is similar to block volume, but the idea here is it's temporary storage locally attached to the compute instance. So see, there is not no more going to the remote storage here like block. You're just directly attaching the storage, but it uses the same construct. It's still block based, etc., etc., but and very high performance, but it's directly attached. Now, this is designed for applications that require high performance. So NoSQL, in-memory, scale-out transactional databases could all use it. The thing to keep in mind is storage is non-persistent, but it survives reboot. So if this instance dies, your storage dies here. So still a block-based storage service, but it's local attached. So it's not durable at all, unlike block volume service. The local NVMe, like block, uses NVMe, so gets very good performance. We don't provide any RAID, snapshots, backups, none of that, like you saw in the previous slides for block volume. Like block volume, it does use block-based protocol. And then we have SLA around performance because, again, these are locally attached. We feel good about these numbers, so we have an SLA around these numbers. If you're using this dense IO shape, you would get something like a 3 million IOPS if you use local NVMe. Well, so until now we looked at block storage, we looked at local NVMe. Let's look at the third flavor of storage, which is file storage. So before we get into the OCI file storage service, let's talk about what is a file storage. Well, file storage is a hierarchical collection of documents organized into named directories, which themselves are structured files. So all of you are familiar with it. This is your local hard disk where you create folders, you keep your documents, your pictures inside those folders. The difference is distributed file systems make distributed look exactly like local file system. So this is an example of a file system. You have folders starting with root. Well, this I took from a Unix documentation, and you have folders within the root, and then you have subfolders and you keep files in them, right? The idea is you take this concept and now you use it on a distributed level. The two most common file standards are NFS and SMB, server message block, network file storage. They are supported by both Unix and Windows, so it's not like NFS is only Unix, supported by Windows. You could create, delete, read, write, share, lock files as files using these protocols or these standards. It's supported by all major operating systems and hypervisors, so it's not like NFS is only Linux and SMB is only Windows. And typically, you don't need extra client software for file storage. And then, like we said, the file storage is basically a distributed storage accessed over network, at least in the cloud construct. And typically, where do you see them? you see them in network attached storage. So file is typically seen in network attached storage, and block is typically seen in on-premises world storage. So these are the places where you would see them commonly in on-premises environment. So let's talk about OCI file storage service. As you can see here, the whole idea behind a file storage service is it's giving you a shared place where you could write your files, and here you could create your folders. You can have subfolders, etc. Right? Shared. This instance can write. This instance can read, and both of them, right? So, like I was saying, it's a shared file system storage for compute instances, as you see in the picture. Today, we only support NFS, and we support NFS version 3. We do allow, like block volume, you have features for taking backups called snapshots. And like block volume, we do encryption for data at rest and in transit. We allow both, not just for the data, but also for the metadata. So what are the use cases for block for file storage? Well, some Oracle applications require file storage, like EBS. They require a clustered file system where multiple instances can write. The application is built like that. Lots of high performance computing scenarios use shared file storage, big data analytics, and then there are general purpose file systems. The NAS systems I was talking about earlier, you can use cloud to replace your general purpose file system. These are very common in enterprises where you have, I'm sure all of you have seen remote storage where you can remote drives where everybody can keep like their backups and like common storage for projects, etc. Right? So pretty common general purpose file systems. Well, like block volume, file storage is also highly durable. So if this instance dies, dies, your file storage is actually is quite is durable. So the service itself replicates the data in three separate fault domains. Now, like block volume, your job is not just done with it. What you could do is you could take snapshots of file systems that provide a read-only space-efficient point-in-time backup, and so you could keep take a snapshot of this file. Why would you do that? Well, the data can get corrupted. You can accidentally delete a file, so you should always do like black volume. You should also always do backups. In case of file storage, those are called snapshots. You can restore a file within the snapshot, or or an entire snapshot using commands like copy or rsync. Well, so that's all about file storage. Let's look at the last storage offering we have and the two flavors we have in that, called object storage. So in case of an object storage, all data, regardless of content type, is managed as objects. An object is stored in a bucket. Think about bucket as a logical container for storing objects. So you have a bucket here. These are your objects which you are storing within the bucket. It's as simple as that. These are stored in single flat structure without a folder hierarchy, unlike file storage. This means that accessing individual objects is fast and easy. It's massive at the speeds at which you can retrieve these objects because it's very flat hierarchy. You don't have to go in a hierarchical fashion looking for like a B tree and like all complex kind of algorithms. You don't have to do any of that. Each object is composed of the object itself and the metadata of the objects. This is again unlike, if you recall, block volume doesn't store any metadata. So this makes it very easy to index and access data, unlike block volume, right, where there's no metadata stored. Object storage is quite common in cloud-based scenarios. You could guess why. Well, it's highly scalable. It's very easy to index access, massive scale. It gets because of that, and it's highly reliable because you don't maintain this folder structure, so you could keep multiple copies. While files and blocks are generally available to an operating system, you could use by using mount operation. Object storage relies on standard HTTP verbs. So you put an object, you get an object, right? So it's a completely different mechanism by which you access object storage. So in OCI, we have an object storage service, we talked about earlier. It's an internet scale high performance storage platform. You could store unlimited amount of unstructured data, whether it's images, media, files, logs, backups, etc. It's a regional service not tied to any specific compute instance, right? You don't do mount operation, you get objects. And we have two different classes, hot storage and cold storage, and we'll talk about each of these in the next slide. What are the use cases? Well, should be pretty obvious. It's a content repository for data, images, logs. You could do archive backup for long periods of times. You can store data for analysis, things like log data, etc. You could store large data sets like genome data or IoT data, and then you have this can be used as a storage for big data, Hadoop, etc. Now, object storage, like file and block storage, is also highly durable. So if you see here, we make the service makes copies in three separate fault domains in an AD like file and block. But if we are running in a multi-AD region, because it's a regional service, we store replica of data in more than one AD. So here you can see three copies made, and here you can see three copies made. In total, making six copies. Of course, this is the case when you have a multi-AD region. Uh, Data integrity is actively monitored and corrupt data detected and auto repaired. That's one of the key characteristics of an object storage. It's massively reliable and highly durable. And you can always leverage cross-region copy for disaster recovery scenarios. We have a feature where you can copy object storage between two different regions if you have DR scenarios. Well, so what are the tiers of object storage? So first tier is called standard storage tier. It's also referred to sometimes as hot storage. And what it means is the storage retrieval is fast, immediate, and instantaneous. You put an object in object storage and you get it instantaneously. There is no like sort of a time lag. We always serve the most recent copy of data when retrieved, and there are some restrictions. If you do this, your object always stays in this particular tier, right? So when you create the tier in OCI object storage, you actually choose whether it's a standard tier or whether it's going to be an archives tier. So that brings me to the next tier, which is the archive tier. Now, as the name suggests, this is for data archival, for seldom or rarely accessed data, which must be retained and preserved for long periods of time. Why would you use it? Well, obviously you are retaining data for a longer period, but it's 10 times cheaper than the standard storage. So that makes it very attractive to keep as much data for depending on your requirement for longer periods of time. There are some restrictions which come with that. There's a 90-day minimum retention period for archive storage, and then yeah, there is when you retrieve the data, unlike the standard tier, the time to first byte is 4 hours before you can start getting your data. So some restrictions around the trade-off being it's 10 times cheaper. The trade-off being there are some certain restrictions, whether it's the duration you have to keep the file for, or whether the time it takes to download the file. You have to it's a trade-off between those things. All right, so let's look at all these side by side. So we looked at local NVMe. The main thing here, it's temporary storage. Keep that in mind. Block, it's persistent storage, unlike local NVMe. File, we have a NFS v3 compatible system. Object, highly durable. Archive, use case being long-term archival and backup. Access, the first two are block level services. File, of course, is file operates at the file level, and then object is a different characteristics operate at the object level. The structure is it's block level structure. This is block level structured, very structured. You give these chunks of blocks, numbers, and you keep them. File is hierarchical. Object is all about unstructured, right? You could put anything in here, and they are treated as objects. Durability, most important thing to keep in mind, non-persistent, though it survives reboot, but if the instance dies, storage dies. Block, most important reason why you would use block, durability. We maintain three copies within an AD in three separate fault domains. Same thing with file, highly durable. Same thing with object storage. It's actually highly durable within multiple ADs, and same thing with archive storage. It's highly durable within across ADs. Capacity, you can see some of the numbers. We didn't go through those numbers. And then the use cases right here, you can see um, for local, it's OLTP, NoSQL, block databases, VMware, Windows workloads, any kind of workloads which require SAN like performance, file, general purpose file systems, certain Oracle apps, HPC, etc. Object is unstructured data, logs, images, videos, and archive storages. Of course, backup and long-term archival, things like your database backups. Well, folks, that's it. That's the module on OCI storage services. Hopefully, it gave you a good understanding of the various storage services we offer, the use cases, the different characteristics, and why you would choose them. Thank you for joining this module. In the next module, we'll talk about some other OCI services. Thank you.